Let's discuss the order of reaction and its determination. As the sum of all the exponents to which the concentration in the rate equation are raised is called order of reaction. Or it would be also referred as the number of reacting molecules whose concentration alter as a result of a chemical change is called order of reaction. For instance, we have a general reaction which is A into A plus B into B gives us product. So its rate equation will be dx by dt equal to K into concentration of A into B. As in both exponents there is A and B. So to measure the order of reaction, we will make a sum of A and B, and this will be order of reaction. As there are some important points to discuss about the order of reaction which are given below, the order of reaction is an experimentally determined quantity and cannot be inferred simply by looking at the reaction equation. Means to determine the order of reaction, we have to perform an experiment between the different reactants and products, as it can't be determined by just theoretically viewing the reaction equation. The sum of exponents in the rate equation may or may not be same as in the balanced chemical equation. The order of reaction provides the valuable information about the mechanism of a reaction, as that's why it compels you to measure the order of reaction, because it may vary different processes. Maximum order of reaction is 3, as the order can't exceed the number 3. Order of reaction can be 0 or can be in fractions. Order of reaction is related with the rate equation and is controlled by the rate law. Order of reaction helps us to determine the mechanism of reaction, and if the molecularity and the order of reaction is same, then it is said to be a simple reaction. Otherwise, it's a multi-step reaction, and this is one of the most important points, as it's used in measuring the rate determining step. So it means that if the molecularity and order of reaction is same, then we have not to worry about the rate determining step. This means that it's a simple reaction. But if they both are not same, then it will be a multi-step reaction, and we have to find the rate determining step, about which we have discussed before. As the chemical reactions are classified into 6 types, which are zero order reaction, first order reaction, second order reaction, third order reaction, pseudo first order reaction, and fractional order reaction. As the order of reaction can be found by comparing the initial rates of two reactants or products knowing concentration. Once the order has been found, the rate constant can also be calculated. As there are some examples of some order of reaction, as the zero order reaction has an example which is the photochemical reactions. As the photochemical reactions are usually zero order reactions, those reactions are the zero order reactions in which the rate of reaction is independent of the concentration of reactants. As the reaction between the carbon dioxide and water is a very quick reaction, so its rate is independent of the concentration of reactants. That's why it's a zero order reaction. As here's an example of first order reaction, which is the decomposition of 2N2O5. As this reaction is the first order reaction because in this there is no change in concentration of reactants occurs. That's why it's a first order reaction. And the second order reaction has the example, the nitric oxide plus ozone gives us NO2 plus O2. As the sum of the concentrations of the reactant is 2, so that's why it's a second order reaction. And the third order reaction is given as 2 nitric oxide plus chlorine gives us 2 NOCl, which is referred as nitrosyl chloride. As in this, the sum of concentration of the reactants is 3, so it's a third order reaction.